You've seen it, right? Generative AI writes a poem or creates this incredible image out of thin air, and it just feels like magic. But today, we're going to pull back that curtain. We're going to look at the machinery and, yeah, the money that makes all of this incredible stuff actually work. There's this idea that behind every one of those amazing creations is just a staggering amount of digital thinking. It's this massive, completely invisible computational effort that's happening every single time you ask a question and get that perfect answer back. So that leads to the big question, doesn't it? What is the actual real-world cost of all this digital thinking? In this explainer, we're going to connect the dots between this incredibly complex technology and its very, very real price tag. Okay, so to really understand the cost of generative AI, it actually helps to first understand what it isn't. You see, AI models really come in two main flavors, and the difference between them is absolutely key to understanding the economics of it all. Think of it like this. On one side, you've got discriminative AI. These are the expert sorters. Their entire job is just to label things. Is this a cat? Yes or no. Is this email spam? Yeah. But on the other side, you have generative AI. These are the artists. They don't just sort what's already there, they create something brand new. And while being an artist is a lot more work, computationally speaking, than just being a sorter. So if these artist models are such power hogs, how did we even get here? What was the big breakthrough? Well, it all comes down to one absolutely brilliant idea, an engine that completely changed the game for language AI. And that game changer is called the transformer. See, before the transformer came along, AI really struggled with long sentences. The older models would just get lost. They'd literally forget the beginning of a paragraph by the time they got to the end. The transformer cracked that problem wide open. Its superpower is this incredible mechanism called self-attention. Now, instead of reading a sentence from left to right like we do, it looks at the entire sentence all at once. This lets it weigh the importance of how every single word relates to all the others, seeing the whole picture simultaneously. It's a totally different way of reading. It basically works in this little three-step dance. First, the encoder just inhales the entire piece of text. Then the attention mechanism gets to work, building this incredibly complex web that connects all the words and their relationships. And finally, the decoder starts writing a response, but it's constantly checking back with that web to make sure every new word it adds makes perfect sense in context. And all of this brings us to probably the most famous acronym in tech today, GPT. The name itself basically tells you the whole story. The G is for generative. It creates new stuff. The P is for pre-trained, meaning learned from a mind-boggling amount of the internet. And that T, that's for transformer, the self-attention engine that makes the whole thing go. But here's the catch. All of that incredible power, that ability to understand context like never before, it doesn't come for free. In fact, that amazing attention mechanism comes with a really, really brutal price tag. That self-attention mechanism, the very thing that makes these models so smart, is also a computational monster. Think about it. For every single word you add to your prompt, the model has to recalculate its relationship to every other word in the entire text. It's a huge amount of work. Now, this brings us to the math. And don't worry, we're not going deep. But there's a concept called Big O notation that programmers use to figure out how much work an algorithm has to do as you give it more data. And for our purposes, there's only one part that really matters for the cost. That n squared right there, that means the cost doesn't just go up in a straight line. It explodes. The key takeaway, the thing you have to remember is this. If you double the length of your text, you don't just double the cost, you quadruple it. That right there is the price of attention. And this isn't just some abstract computer science concept, okay? That explosive n squared cost translates directly into cold hard cash. Let's take a look at how that actually works. So when people talk about how big an AI model is, they're usually measuring three things. First is model size, which is the number of parameters. Think of them like billions of tunable knobs. Then there's data size, which is the massive library it learned from. And finally, compute size, the raw processing power it took to train it. And this translates directly into what you pay. A simple model for a straightforward task has a base cost. But if you need a more advanced one for multi-step tasks, the price can jump by 10 times. And for the most powerful models, the ones that can do complex reasoning, you could be looking at 100 times the cost. You are literally paying for every single extra calculation driven by that n squared problem. So, as you can imagine, the race isn't just about building bigger and bigger models anymore. A huge amount of effort is now focused on making them smarter, way more efficient, and frankly, more trustworthy. While all the giant models are getting the headlines, there's this quiet revolution happening with what are called small language models, or SLMs. These are lean, efficient models designed to run right on your phone or your laptop. And that means you get more speed, much better privacy, and they can even work offline. Another really clever innovation is something called Retrieval Augmented Generation, or RAG. This is basically a fix for when AIs hallucinate, when they just make stuff up. Before a RAG model gives you an answer, it first searches a trusted database for actual facts to ground its response. It's like giving the AI its own personal fact-checker, sitting right on its shoulder. So we've covered how these things work and what they cost, but this all leads to a much bigger, almost philosophical question about what the future of AI is even supposed to be. It feels like we're at a fundamental fork in the road. On one path, you have today's large language models. At their core, they are prediction engines. Their goal is just to master probability to guess the next best word. But the goal of cognitive AI, the other path, is totally different. It's about simulating human thought, to reason, to adapt, and to actually understand why. This fantastic analogy frames the whole debate perfectly. Are we just getting better and better at making an omelet, which is a complex but ultimately finished product? Or are we about to see that egg crack open from the inside to give birth to a bird, something that can grow and learn all on its own? And really, that's the question that's going to define the entire next chapter of AI. Is the end goal a perfect, finished product, or is it something that can truly grow? That's what everyone is trying to figure out right now.